In this video, we'll be looking at transformation of vectors in 2 dimensions. So far, we've been working with elements that have local axes that are oriented in the global axis, within the global axis. So we did not have to go through any transformation. But in general, we're going to have our elements with their local orientation and local axis that are different than the global axis. So in this figure here that we're looking at, we may define x, y as the global axis and x prime, y prime as a local axis. And we are looking at a vector d. We're looking at this vector d that is neither oriented along the x prime axis nor is it oriented along the x axis. We want to be able to relate d in the local axis to d with respect to the global axis. So first, I'm going to express the vector d in terms of, or with respect to, the global axis as ui plus vj. Next, I'm going to express the vector d with respect to the local axis as u prime I prime plus v prime j prime. We can, looking here at the geometry, we can say that this u prime is equal to, and when I'm looking at u prime, I'm looking at the distance O to C. So I can say that this is OC, and this is equal to, the first portion would be u cosine theta, so be from here to here, and then I have a second component which is v sine theta. So I can write it here as u cosine theta plus v sine theta. Next, we'll be looking at v prime, and v prime is the same as the distance here, CB. So it is this distance here. So this is v cosine theta minus u sine theta. So when I'm going to write it down here, I'm going to start with I'm going to say this is equal to CB, where CB is equal to minus u sine theta plus v cosine theta. Please note that theta is the angle between x and x prime. And you see here theta is taken in the counterclockwise direction. Next, we're going to let cosine theta be equal to uppercase C and sine theta equals to uppercase S. In matrix form, I can write u prime v prime in terms of u and v, and I'm going to have here my matrix, my transformation matrix. So I'm going to fill here. I have cosine theta u plus sine theta v, and here I have minus sine theta u, and here I have a plus cosine theta v. This here gives me d prime as a function of D expressed in the global axis via the transformation matrix T. So I can say here that D prime is the local displacement vector D is the global displacement vector T is the transformation matrix, and theta is the angle from the global axis to the local axis. This is axis. The transformation matrix is also sometimes referred to as the rotation matrix. In the next video, we'll see how to use the transformation matrix to go from the stiffness matrix expressed with respect to the local coordinates to the stiffness matrix expressed with respect to the global axis.